All right, let's go over some of these problems from the rational exponents and radical functions unit. We're going to go through problems numbers 5, 10, 14, 21, and 24. All right, problem number 5 was 8 to the 5/3 power. Now, one thing we could do is rewrite this as a radical if we wanted to. We could say the third root of 8 to the 5th power, because the denominator is actually a root and the numerator of the exponent is the power. So when you look at it this way, I always like to do the root first. So the third root of 8 is 2, because 2 times 2 times 2 is 8. So this is really like 2 to the 5th power, because all of that parenthesis just becomes 2, and 2 to the 5th power is 32. Okay, in this one we have a 5th root of 16 times the 5th root of 8. But since 8 and 16 both are, you're taking the 5th root of both of them, you can actually combine those together into one problem. And write them under the same radical this way. And so 8 times 16, 8 times 8 is 64. 64 times 2 is 128. So the 5th root of 128. All right, when I see 128, I know it's the various powers of 2. So 128 is actually 2 to the 8th power. Nope, it's 2 to the 7th power. So that's cool. So this I can rewrite in exponent form as 2 to the 7/5, which I can rewrite as 2 to the 5/5 times 2 to the 2/5. And there's really nothing you do with the 2 to the 2/5, but 2 to the 5/5 is 2 to the 1st. That's 2. So this is 2 times the 5th root of 2 squared, which is the 5th root of 4. That's the best answer I have for that one. Okay, I'm taking the 4th root of 2x to the 6th y to the 8th z. So each and every one of those terms are going to be taking the 4th root of. I could write it out that way. I think that's what I'm going to do. I'm going to write, stop doing that, 2 to the 1/4, x to the 6/4, y to the 8/4, and then z to the 1/4. All right, if any of these fractions are greater than 1, like 6/4 and 8/4, that means I can actually remove an entire variable from the 4th root. So I'm going to rewrite these with x to the 4/4 taken out, and then there'll be x to the 2/4 left over, and then y 8/4 is just y squared, and I could take that whole thing out. So let me just do that. 2 to the 1/4 times x to the, I'll call this 4/4 times x to the 2/4. Remember, when you multiply those, you actually end up adding their exponents. And then times, I'm just going to call that y squared, because 8/4 is just 2. And then z to the 1/4. All right, we get a couple cool things here. X to the 4/4 is just x to the 1st, and y squared, that's a normal number. I'm going to write those in front, and then I'm going to write that as x to the 1st, or just x, y squared. because those can all be rationalized. And then everything else I'm going to write underneath the fourth root. So there was nothing we can do with the 2. We'll write an x squared because there's a numerator of 2 on the x to the 2/4. And then z to the 1/4. We'll just put the z underneath there. And that's fully simplified. All right, now we have a composition of functions. We're going to put the function g of x in for the variable of f of x. So it's f of g of x. In this problem, I am going to write g of x first. And then I'm going to put that into the f of x. So I'm going to put that in parentheses. On the outside, I'm going to put it 2 plus 9. So we have 2 times 3x minus 1 plus 9. And that's what f of g of x is. Now, it's not fully simplified. We can go through and simplify this all the way. Multiply the 2 times 3x minus 1. So that would be 6x minus 2 plus 9. And we can combine like terms here. We have a minus 2 and a plus 9. So that would be plus 7. So f of g of x equals 6x plus 7. All right, we're going to find the inverse function of f of x equals 1/3 x plus 4. The first thing I'm going to do is change it into y notation. So y equals 1/3 x plus 4. Now we need to take the inverse of this. So I'm going to swap the x and y. I'm going to say x equals 1/3 y plus 4. The only thing I changed were where the x was and where the y were. I swapped their locations. Okay, now we can solve this for y to get y by itself. So I'm going to subtract 4 from both sides. X minus 4 equals 1/3 y. And then I'm going to multiply 3 by both sides. All right, now I'm going to write it back in function notation. So I'm going to say f inverse of x equals, and then I'll distribute 3x minus 12. Those are inverse functions. All right, good luck.